Hello everyone, my name is Alicia Serfati de Marcos and I have created this simple animation on piecewise functions with the purpose to help you understand what is actually a piecewise function, how it works, and how to graph it. This is an equation in two variables, x and y, where the y variable has been isolated on the left side, and thus we can replace it by the symbol f of x that we use in function notation. So here we are reading f of x equal 5x minus 5, one formula, one piece. But what if f of x could be equal to more than one formula? What if could be equal to a set of formulas? For example, the three formulas that you're looking here together with three conditions, or maybe two formulas and two conditions. In general, a piecewise function is a set of formulas and a set of corresponding conditions as we are seeing here. Formula 1 will go with condition 1. Formula 2 will go with condition 2, and formula 3 will go with condition 3. Let's make an example that we will make three formulas. Say formula 1 is f of x equal x plus 2, which is the equation of the line that you're looking in here with the two lines extending left and right. Let's assume that the condition goes x being less than -1. That defines the interval that you're observing here to the left of -1 in the real axis, x. Because of this condition, everything to the right of -1 has been to be erased. So we will keep only the first part, the first piece. And in this process, we have shown how to create the first piece of our piecewise function. Let's have now formula 2 being equal to the quadratic equation negative x to the second plus 3x plus 6, which is this familiar parabola upside down. And let's have in this example for this formula will be that x has to be between -1 and 4. That defines the interval indicated in the real x-axis. For that reason, only on that interval we can keep the function defined, and everything else has to be deleted. Therefore, with this process, we have our second piece. Let's have now formula 3 and condition 3 given as formula 3, the square root of x, which starts at 0 and extends all the way to the right side as shown in here. And let's have condition 3, such as x being greater or equal than 4. That will define an interval that starts to the right of 4, as indicated in here. One more time, because of this interval, everything outside it has to be erased and deleted, and we only will keep that part of the function, square root of x, that corresponds to that interval. And with this process, we have found our third piece. If we have considered the three formulas as three different equations, we will have a graph as the one shown in here. However, such a graph as a set can never pass the vertical line set test because it has too many intercepts. However, consider that the three formulas corresponds to a single function with the given conditions. That means that we have to erase all of these parts corresponding to the conditions imposed by the functions formulas. In this case, our formulas will look like these ones in here. Now, we now have to consider what happens in the locations where the intervals, condition intervals, starts and stops. For example, for x being greater or equal than -1, that means that for the second formula, in the left side, we consider that the number -1 belongs to this interval. So we will represent that with a solid dot. However, for the condition of the first formula, which is x being strictly less than -1, -1 will not correspond, will not be part of the interval of the red one. And then we have to indicate that with a open dot. Here, actually, we are observing that our function have a gap. That doesn't happen in the third condition because for x being greater or equal than 4, the two formulas coincide at x equal 4 and no gap is observed. If to this graph now we apply the vertical line test, we will see that we will have only one intercept as expected for a function. Therefore, the vertical line test is passed. I hope that this simple animation have helped you to understand what is a piecewise function and to interpret its graphs. Thank you very much.